Hello, in this lecture we will find out the area of trapezoid ABCD. In the drawing we have trapezoid ABCD. This is side AB that is equals to 2 units in its length. We know that side BC equals to side CD, and those two angles are right angles. Again, our mission is to find out the area of this trapezoid ABCD. So, what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. This trapezoid ABCD, side AB is parallel to side DC. So, here, a trapezoid is a quadrilateral with one pair of parallel sides. In this trapezoid ABCD, side AB is parallel to side DC. And those two parallel sides, AB and DC, are defined as the basis of this trapezoid ABCD. And what is the area of this trapezoid ABCD? The area is equal to the sum of its two bases, that is to say it is A plus B, times the height h over 2. Again, the area of this trapezoid ABCD equals to the sum of its two bases. The two bases are the two parallel sides, that is AB, that is B, and DC, that is A. So the sum of its two parallel bases is A plus B times the height h over 2. Okay. We also know that the perimeter of this trapezoid ABCD is equal to 16 units. Okay, so first of all, we will define the length of this side AD as A. We will define the length of side DC is B. That is to say, side DC is equal to B units in its length. And because of the fact that according to what is given as the question, side BC is equal to side DC. So if DC is B, then BC must be also equal to B units in its length. And you know that side AB equals to 2 units. And we know that the perimeter of this trapezoid ABCD is equal to 16 units. That is to say, the sum of its four sides is equal to 16 units. So AB, side AB plus side AD plus side DC plus this side BC, in total they are equal to 16 units. AB is 2 plus AD is A plus DC is B plus BC. BC is also B. So in total, the sum of those four sides of this trapezoid ABCD is equal to 16 units. Equal to 16. So A plus 2, here B plus B, that is 2B. In total, it is equal to 16. Here we subtract 2 from this equation and get that A plus 2B is equal to 16 plus 2 is 14. So A plus 2B equals to 14. So here we will subtract 2b from this equation and we get that a equals to 14 minus 2b. So let's find out that a, that is the length of side AD, is equal to 14 minus 2b units. Okay. In the next step, we will do a construction, that is to say, from this point B, we will draw perpendicular on DC. Then from point B, we will draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. Okay, by doing this construction, we can do quadrilateral ABMD. Inside this quadrilateral ABMD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. From 270 degrees plus the size of this fourth pieces angle, in total it must be equal to 360 degrees, according to the rule that states that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this fourth pieces angle must be equal to 90 degrees in its size. In order to complete the sum of the angles inside this quadrilateral to 360 degrees, this angle must be equal to 90 degrees in its size. So inside quadrilateral ABMD we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this left angle in front of square. So we relate to this quadrilateral ABMD as a left angle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in this rectangle ABMD, side AB must be equal to the opposite side DM. But AB is 2, therefore the opposite side DM must be also equal to 2 units in its length. Likewise, according to the sum rule, in the sum rectangle ABMD, side AD must be equal to the opposite side BM. But AD equals to A, that is 14 minus B, therefore the opposite side BM must be also equal to A, that is 14 minus 2B. Okay, what is the length of this missing 97 MC? From the drawing it is very easy to see that MC equals to DC minus DM. Again, DC minus DM equals to MC. So already known, the missing side MC is equal to DC minus DM. So MC equals to DC. DC is B according to our definition, minus DM. We just right now found out that DM equals to 2. So in total, MC equals to B minus 2 units. We can write here that MC equals to B minus 2 units. So in the next step, I'll copy this right triangle BMC in a new page, and we will implement the Pythagoras theorem on this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually, this is the right triangle BMC that I copied from the original drawing. This triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, must be equal to BM squared plus MC squared. So I write it down. BC squared, that is the square of the hypotenuse, is equal to BM squared plus MC squared. BC equals to B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus 2B, therefore BM squared is 14 minus 2B squared. Plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, according to the Pythagoras theorem, in this triangle BMC, we found out that B squared equals to 14 minus 2B squared plus B minus 2 squared. So here we open the brackets on this side of this equation, and we get that B squared is equal to B minus to 14 minus 2B squared. 14 minus 2B squared equals to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14 minus 2B. Minus 2 times 14 is minus 28, and 28 times 2B is minus 56B, plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2 is minus 4B. So here we have B squared on both sides of this equation, so B squared will get cancelled. In this side of the equation, we left with nothing, that is to say 0. Well, in the other side of this equation, we have 196 plus 4 is 200. And we have here minus 56b minus 4b is minus 60b. And we have here 4b squared. So to that, we should find out that zero equals to 200 minus 60b plus 4b squared. Here we will divide this equation by 4. And we get that 0 over 4 is 0. It is equal to 200 over 4 is 50. Minus 60b over 4 is minus 15b. And 4b squared over 4 is b squared. So in total, we should find out that b squared minus 15b plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Another specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0. The variable that we are looking for is b. So x equals to b. The coefficient a equals to 1. The coefficient b equals to minus 15. And finally, the coefficient c equals to 50. The only thing that is left to do is to put the data for our specific quadratic equation in order to find out the value of the values of b, because x equals to b. So we do it now and get that again here x equals to b. So we substitute x by b. So b equals to minus b. The coefficient b is equal to minus 15. And therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. B is minus 15, therefore b squared is minus 15 squared, that is 225 minus 4 times a times c. So it is minus 4 times a. A is 1, minus 4 times 1 is minus 4, times c. C is 50, so we have minus 4 times 50 inside the root, divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So if we found out that b, that is the variable that we are looking for, is equal to 15 plus minus square root of 225 minus 4 times 50 is minus 200 divided by 2. So b equals to 15 plus minus 225 minus 200 is 25, and the square root of 25 is 5. So total, if we found out that b equals to 15 plus minus b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. We will define the first solution as b1 and the second solution as b2. So the first solution b1 will be equal to 15 plus 5 over 2. And again, the first solution is b1. This is equals to 15 plus 5 over 2. 15 plus 5 is 20 over 2. So 20 over 2 is 10. So total, if we found out that b1 equals to 10. The first solution for b is b1, that is equals to 10 units. We have also the second solution for b, that we define as b2. b2 equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is equal to 5. We know that AD equals to A and A equals to 14 equals to B. So that is known. AD equals to A and A equals to 14 equals to B. But AD is a length, because of the fact that AD is a length, it must be a positive number. That is to say, AD is equals to A, and A equals to 14 minus 2B is a length, and therefore it must be a positive number. What is a positive number? It must be greater than 0. Okay? So we have here the inequality that says that 14 minus 2B equals to 0. Here we add 2B to this inequality, and we get that 14 is greater than 2B. Here we divide this inequality by 2, and we get that 14 over 2 is 7, greater than B, or B is less than 7. B is smaller than 7. So if B is less than 7, B can never be equal to 10. So the first solution for B, that B equals to 10, is the incorrect solution. We cancel this solution and we left only with the second solution that is possible for B, that is B2 equals to 5. B, that is 5, is less than 7. Okay? So this is the only solution that is left for B. So B equals to 5 units in its length. Our mission is to find out the area of this trapezoid ABCD. So what is the area of trapezoid ABCD? Actually, according to the formula that I presented to you, the area of trapezoid ABCD will be equal to the sum of its two parallel bases, that is to say AB plus DC, times the height divided by 2. The height must create 90 degrees with the two bases. Here AD creates 90 degrees with the two parallel bases, therefore AD is the height divided by 2. And again, the area of this trapezoid ABCD is equal to the sum of its two parallel bases, that is actually AB plus DC, times the height AD over 2. AB equals to A and A equals to 14 equals to B. We just right now found out that B equals to 5. So minus 2 times 5 is minus 10. And 14 minus 10 is 4. So A equals to 4. A equals to 4, and it is AD. So we substitute AD by 4. Inside the brackets we have AB plus DC. AB is 2, so we substitute AB by 2 plus DC. DC in total equals to 2 plus P minus 2. B is 5, so 5 minus 2 is 3. And 3 plus 2 is 5, so in total BC equals to 5. So we substitute BC by 5. Yeah. We substitute, it is actually DC. DC in total equals to 2 plus 5 minus 2, that is 3. 3 plus 2 is 5, so DC in total equals to 5. So we substitute DC by 5 divided by 2. So in total we should find out that the area of trapezoid ABCD equals to 2 times 5, 2 plus 5 times 4 over 2. So it is 2 plus 5 is 7, and 4 over 2 is 2. So in total this expression equals to 7 times 2, that is 14 square units. So I should find out that the area of trapezoid ABCD is equal to 14 square units. And that is the answer to the question. Repeat again, we shall find out that the area of this trapezoid, that is the area that we are looking for this question, is equal to 14 square units. Okay, so in the next step I'll summarize the lecture. So in this lecture I found out the area of this trapezoid ABCD. So what is a trapezoid? A trapezoid is a quadrilateral with one pair of parallel sides. In this trapezoid ABCD, side AB is parallel to the opposite side DC. and the two parallel sides are defined as the bases of trapezoid ABCD. And what is the area of trapezoid ABCD? Actually, the area of any trapezoid is equal to the sum of its two parallel bases. In this case is A plus B times the height, that is h over 2. The height h must create 90 degrees with the two bases. You can see here that the height h creates 90 degrees with the base DC, and the height h also creates 90 degrees with the base AB. So in total, if you found out that the area of trapezoid ABCD equals to the sum of its two parallel bases, in this case it is A plus B, times the height, that is h over 2. We also know that in this trapezoid ABCD, side AB equals to 2 units in its length. We also know that side BC is equal to side DC. And those two angles are right angles. Again, our mission is to find out the area of this trapezoid ABCD. And we also know that the perimeter of this trapezoid ABCD is equal to 16 units. What is the perimeter? The perimeter is the sum of its two four sides. The sum of its two four sides is 16 units. Again, our mission is to find out the area of this trapezoid ABCD. So, we define the length of side AD as A, and we define the length of side BC as B. And because of the fact that DC equals to CB and DC equals to B, therefore BC must also equal to B. And we know that the perimeter of this trapezoid ABCD is equal to 16 units. That is to say, AD plus DC plus CB plus BA equals to 16 units. Again, AB plus AD plus DC plus BC equals to 16 units. AB is AB is 2. AB equals to 2 units in its length according to our definition, according to what is given as the question. AD is A, AD is A, DC is B, and BC is also B. Again, DC is B and BC is also B. So in total, I have found out that 2 plus A plus B equals to 16. That is the perimeter of the trapezoid ABCD. So here we have A plus 2 plus B, that is 2B equals to 16. So A plus 2 plus 2B equals to 16. We subtract 2 from this equation. And finally found out that A plus 2B equals to 16 minus 2 is 14. Here we subtract 2B from this equation, and finally found out that A equals to 14 minus 2B. So this is side AD, this is equal to A according to our definition, and A equals to 14 minus 2B. In the next step, we did a construction. That is to say, from this point B, we draw perpendicular on DC. Again, from point B, we draw perpendicular on DC. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and DC. This point is point M. By doing this construction, we get a quadrilateral AB, MD. Inside this quadrilateral AB, MD, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle. In total, they must be equal to 360 degrees according to the rule that says that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore, this fourth missing angle must be equal to 90 degrees in size. In order to complete the sum of the angles inside this quadrilateral to 360 degrees, this missing angle must be equal to 90 degrees in size. So inside quadrilateral ABMD, we have 4 right angles. And according to rule 5, any quadrilateral that has 4 right angles must be a rectangle if not a square. So we relate to this quadrilateral ABMD as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle ABMD, side AB is equal to the opposite side DM. But AB is 2, therefore the opposite side here must be also equal to 2 units in its length. Likewise, according to the same rule, the same rectangle ABMD, side AD must be equal to the opposite side BM. But AD is 8, is equal to 14 loss 2B, therefore BM must be also equal to 8, that is 14 loss 2B. Okay. What is the length of this missing thread MC? From the drawing it is very easy to see that MC equals to DC minus DM. Again, DC minus DM equals to MC. Okay, again, MC equals to DC minus MD. So MC equals to DC. DC is B according to our definition, and DM we just find out that DM equals to 2. So in total, MC equals to B minus 2. MC equals to B minus 2. According to our definition, BC equals to B. So in the next step, I copied this right triangle BMC in a new page and implemented the Pythagoras theorem in this right triangle BMC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay. Actually, this is the right triangle BMC that I copied from the original drawing. In this triangle BMC, according to the Pythagoras theorem, BC squared, that is the square of the hypotenuse, equals to BM squared plus MC squared. Okay, again, BC squared equals to BM squared plus MC squared. BC is B, therefore BC squared is B squared, and it is equal to BM squared. BM is 14 minus B, therefore BM squared is 14 minus B squared plus MC squared. MC is B minus 2, therefore MC squared is B minus 2 squared. So in total, we shall find out that B squared equals to 14 minus 2B squared plus B minus 2 squared. Here we open the brackets on this side of this equation. We found out that B squared equals to 14 plus 2B squared equals to 14 squared, that is 196, plus 2B squared, that is 4B squared, minus 2 times 14 minus 2B minus 56B. And we also here plus B minus 2 squared. B minus 2 squared equals to B squared, plus 2 squared, that is 4, minus 2 times B times 2 is minus 4B. So here we have B squared on both sides of this equation, so B squared will get cancelled. After we cancel B squared in this side of the equation, we left with 0, nothing. In the other side of the equation, we have 196 plus 4 is 200. And we have minus 56B minus 4B is minus 60B. And we have also 4B squared. So in total, we shall find out that 0 equals to 200 minus 60B plus 4B squared. Here we divided this equation by 4. And finally found out that 0 over 4 is 4. 200 over 4 is 50. Minus 60B over 4 is minus 15B. And 4B squared over 4 is B squared. So in total, we shall find out that B squared minus 15B plus 50 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So, in our specific quadratic equation, that is to say b squared minus 15b plus 50 equals to 0, the variable that we are looking for is of course b. So x equals to b. The coefficient a equals to 1, the coefficient b equals to minus 15, and the coefficient c equals to 50. Okay, on the data for our specific quadratic equation, the only thing that we have to do is to put this data inside this general formula for x, and in this way we find out the value of the values of b, because x equals to b. So we done it, and we did it, and we found out that x equals to b. So substitute x by b, and it is equals to minus b. b is minus 15, therefore minus b is minus 15, that is plus 15, plus minus square root of b squared. b is minus 15, so b squared is minus 15 squared, that is 225, and we have here minus 4 times a times c. So it is minus 4 times a is 1, so minus 4 times 1 is minus 4, times c. c is 50, so minus 4 times minus 4 times 50. So b equals to 15 plus minus square root of 225 minus 4 times 50 over 2. Minus 4 times 50 is minus 200, so in total we have found out that b equals to 15 plus minus square root of 225 plus 200 over 2. 225 minus 200 is 25, and the square root of 25 is 5. So in total we have found out that b equals to 15 plus minus 5 over 2. So here we have two solutions that are possible for b. We define the first solution as b1 and the second solution as b2. So here the first solution is b1, that is equals to 15 plus 5 over 2. 15 plus 5 is 20, so 20 over 2 is 10. So the first solution for b is b1, that equals to 10, and the second solution for b is b equals to 15 minus 5 over 2. 15 minus 5 is 10, and 10 over 2 is 5. So the second solution for b is b2, that is equals to 5. We have here, we know that AD is the length of side AD of trapezoid ABCD. So AD is a length, it must be a positive number. And again, AD is equal to A, and A equals to 14 minus 2B. AD is a length, and as a length, it must be a positive number. But AD is 14 minus 2B. That is to say, 14 minus 2B must be a positive number. What is a positive number? It means that it must be greater than 0. So we have the inequality that 14 minus 2b is greater than 0. We added 2b to this inequality and finally found out that 14 is greater than 2b. So here we divided this inequality by 2 and finally found out that 14 over 2 is 7 and 2b over 2 is b. So in total we found out that b is less than 7. b is less than 7. If b is less than 7, or if b is smaller than 7, b can be equal to 10. So the solution b1 is equal to 10 is the incorrect solution. And we're left only with the second solution that is possible for b, that is b2, it is equal to 5. 5 is less than 7, so that is the only solution that is left, that b equals to 5 units. So here we have a equals to 14 plus 2b. b is 5, so 2b is 2 times 5, that is 10, and 14 plus 10 is 4. So a is 4, a equals to 4 units. A is actually the height. So I actually found out that the height is equal to 4 units because AD is the height. AD equals to 4. Here we have b minus 2 is 5 minus 2, that is 3, and 3 plus 2 is 5. So this is 5, AD is 2, and the height AD is 4. So they have this trapezoid ABCD equals to the sum of its two parallel bases, that is to say AB plus DC times the height, that is AD over 2. Okay, again, they have trapezoid ABCD equals to the sum of its two parallel bases, that is actually AB plus DC times the height, that is AD over 2. AB is 2 according to what is given as the question. We already found out that DC is, in total it is b minus 2 is 5 minus 2, that is 3 plus 2 that is 5. So DC in total is 5. So we have AB is 2, DC is 5, and AD is 4. AD is 4. So in total, we found out that the area of trapezoid ABCD equals to 2 plus 5 times 4 over 2. 2 plus 5 is 7, and we have 4 over 2 is 2. So in total, the expression equals to 7 times 2, that is 14. So we found out that the area of trapezoid ABCD is equal to 14 square units in its size. And again, the area of this trapezoid ABCD, that is the area that we are looking for in this question, is equal to 14 square units. Okay, thank you very much.